Hi, today I'll be talking about primary progressive aphasia, or PPA, a rare neurodegenerative condition that's mainly characterized by progressive impairment in language processing. More specifically, I'll relate what we know about the atrophy signatures of 3 known variants of PPA to task-based fMRI to look at whether and to what extent functional activity is altered in these clinical groups, and ultimately to see if these alterations are localized to areas of cortical thinning. So a lot of work has been done to describe the atrophy patterns of the 3 variants of PPA, which I'll introduce with these whole brain maps that demonstrate areas of cortical thinning and are derived from a general linear model comparing each PPA variant group with age-matched controls. So firstly, over here you can see that the semantic variant PPA group, which is characterized by deficits in semantic abilities, such as picture-object naming and single-word comprehension, have the most pronounced atrophy in the anterior temporal areas. As you can see, this group demonstrates bilateral atrophy, but it predominantly is seen in the left hemisphere. Secondly, the non-fluent PPA group down here is characterized by disfluent and effortful speech with errors in grammar and syntax, and at the same time relatively preserved semantic abilities. And they have significantly thinner cortex in areas such as the inferior frontal, middle frontal, and superior frontal areas. Lastly, the logopenic group, uniquely known for impairments in the auditory verbal short-term memory function, also known as the phonological loop function, have the most noticeable atrophy in the posterior temporal areas. So to build off of the work on the structural data, we decided to use a slow version of the Federanco language localizer task to test our patient sample. And the task design that we used contains a sentences condition and a non-words condition, which you can see over here. And by calculating the differences of activity in response to these two conditions, we were able to isolate activity that is specific to higher level language function, while omitting any activation due to more low-level visual processing of looking at the words on the screen. So the PPA sample used for the following functional analysis, starting over here, is actually a subgroup of the PPA patients that were used to create these atrophy signature maps. So we exclude any patients with no available functional data. And for these patients, we created functional regions of interest. So we did this for 2 reasons, and the first reason for creating FROIs was to increase the power of our results by specifically testing the areas relevant to our hypotheses. And the second was to account for any anatomical variability across our subjects, since we already knew that PPA subjects have severe cortical atrophy. So to create these functional ROIs, we use parcels developed by the Federanco lab, which you can see over here. These were derived from 220 cognitively normal individuals and were used as boundary regions to then select the top 10% of vertices based on the t-surface maps, the t-value surface maps shown here. So this ultimately gave us 6 subject-specific regions of interest. And you can see over here an example of the functional ROIs for a particular subject. With these FROIs, we were then interested in 2 metrics. The first metric was the difference in functional magnitude per region for each PPA variant when compared to controls. And the second metric was the difference of overall interregional connectivity, which we calculated by taking the mean of each pairwise correlation of the spatially averaged bold signal of each of the 6 ROIs. So over here you can see a box plot that represents cortical thickness per variant. And as you'd expect, you can see atrophy in the anterior temporal region, most significantly affecting the semantic patients. And similarly, the angular gyrus is most affected for the logopenics, and inferior frontal regions affecting the non-fluent patients to the highest degree. And so these are trends that we would expect. And alongside this, you can see the magnitude of each of these functional ROIs. So the logopenics seem to have the most widespread difference in mean contrast in regions including the anterior temporal, the angular gyrus, and the posterior temporal areas. And for semantics, you can also see that there's a lower magnitude in the anterior temporal area. So to conceptually tie together the comparison that we're trying to make here, I've included maps which indicate areas of significant atrophy in the PPA group as a whole. And you might notice that this map looks very much like the combination of the three maps that you can see over here, which is what we would expect. And under this row of maps, you'll find the mean functional activation for the specific contrast of sentences versus non-words. And so now I'm just going to pause and take a moment to mention two things. And one is that the contrast here seems to be selective to the regions that we know activate in cognitively normal individuals. So for example, you can compare the outline of the activation in these maps to the parcels that we've used up here that were based on the activation of cognitively normal individuals. And we can see that there is quite a bit of overlap, which ensures that the task actually works for the PPA sample. And secondly, you might notice that the two rows of brain maps actually have a high degree of overlap, primarily in the temporal regions. And this conceptually supports the question, how does regional atrophy affect functional activity, which is addressed in these box plots. So lastly, we looked at the interregional connectivity over here, which I described already in the methods section. And you can see here that the logopenic group has the lowest level of interregional connectivity. Or another way to put this is that they have the highest level of overall fractionation of the language network. So at a more granular level, you can see that this effect is mainly driven by the anterior temporal and angular gyrus regions. So these abnormalities in connectivity we thought a bit about, and we thought that maybe it can be supported by the idea that the angular gyrus, the region with the most prominent atrophy in the logopenic group, serves as a central hub of the language network. And so with this, I want to close by mentioning that this work was funded by the NIH, and I wanted to thank my colleagues Jean and Megan, as well as my supervisors Jessica Collins and Brad Dickerson. Please feel free to reach out to me if you have any questions in the chat or in the comments. And thanks for listening.